Let A be an n by n matrix. Then for each I, we have this expression called the cofactor expansion along the ith row, and this expression called the cofactor expansion along the jth column. To remember the signs in this expression, so in other words the signs that are in the ij cofactor, I like to think of this little checkerboard pattern. So we have plus, minus, and so on, minus, plus, minus, and so on, plus, minus, so on, minus, minus, so on, and so forth. So let's look at an example and move this actually over to the side so that it's out of our way a little bit. Let's look at this example. It's the same matrix that we looked at in the last video, but this time I want to show you what happens when you expand along the second column. So let's expand along the second column instead of the first row. Well, we get the determinant of A according to our formula. Well, the first entry in this column, the 0 here, to figure out what sign we use, we go over here and we notice that we have a minus in that position. So we have minus 0, well, minus 0, that doesn't really matter, but for this guy, we have a plus here, so we put a plus 1 times the determinant of what's left over when you remove that row, the 1 is in, and the column that the 1 is in. So it's the determinant of 2, 1, 0, 1, 2, 3, 2, 4, 5. And then for the rest of the column, we have minus 0, plus 0. So we can now continue with what we know about how to compute the determinant of a 3 by 3 matrix. And this is now 2 times, let's see, 10 minus 12 minus 5 minus 6, which is negative 4 plus 1, which is negative 3, just as we got in the previous example. But notice in here we did slightly less calculation, and that was because the column that we chose to expand along had more zeros than the row we expanded along in the last example. Let's take a look at this example here. I'm going to do this example, let's expand along this first column, and that's because that column has the most zeros of any other row or column. When we do this, we get the determinant of A is equal to 2 times the determinant of 3, 7, 10, 0, 4, 8, 0, 0, 5, minus 0 plus 0 minus 0. This is then equal to 2 times 3 times the determinant of 4, 8, 0, 5, because here again I expanded along this first column, that being the column or row with the most zeros. And I could put minus 0 plus 0, but I'm not going to save room. Actually, no, I am going to put them there. Minus 0 plus 0, which is equal to 2 times 3 times 4 times 5 minus 0, which is equal to 120.